Hey guys, welcome back to another one. So, in today's video, we're going to be discussing another IB topic, and specifically, we're going to be discussing IB Science IAs. And more specifically, we're going to be discussing the IB Biology IA or exploration. Now, you see, I'm from the May 2020 batch, so that's the batch that never ended up giving their exams. That meant that almost our entire grade was dependent on our IAs. So if there's one thing in terms of IB that I'm qualified to speak on, that is IAs. And specifically, the biology IA is where my expertise lies, because that was my favorite subject in school, and I scored a 7 in IB biology, and I scored a 7 in the IB biology IA as well. So I'm going to tell you how I did that, what rules I followed, what structure I followed, what format I followed, and all the important things. But before I do that, I want you to go check out my YouTube channel, because over there I make videos about medical school and university. This includes videos on how to get into medical school, how to get into university, as well as videos on medical school and university life, so vlogs, day in the life videos, and a few videos on how to survive medical school and university as well. So if that sounds like something you'd be into, then definitely go check it out and smash that subscribe button and join me for a lot more. So there are four important things to talk about today. The first is choosing your topic. That's the biggest and most important initial hurdle that you have to cross, because the right topic lends itself to a great IA, but one that's not so good will make it a challenge to make an IA that's coherent and flows really well. And then of course choosing a topic, and after that the structure. We'll discuss the structure, so what structure to follow, and I'm going to briefly discuss all the components of the structure that I recommend as well. And after that we're going to talk about format, and lastly we're going to end with a few tips on just general tips on how to make a great IA. So remember that I'm giving these tips in context of the biology IA. However, they're broadly applicable to all science IAs, so chemistry and physics as well. I did have chemistry and physics in school, so I can assure you that these tips will be helpful as well for IB chemistry and IB physics. So right, let's get into choosing a topic. There are a few different things you can choose. You can choose to do an experiment, which involves primary data collection. You can choose to do an experiment with secondary data, so more of a study of already existing data. Or what you can do is you can do some sort of modeling experiment as well. Now, I don't have too much experience with modeling IAs and ones with secondary data. Because mine was one with primary data, it was an actual experiment which involved experimental design, etc. I would recommend that, because it was the one recommended to me as well. What I was told by my supervisors, my teachers, is that primary IAs with primary data are always the best, and that's the main reason for that. Is it allows for a lot more analysis, a lot more discussion, and there are parts of the IA that you can include in one that includes primary data and actual data collection, primary data collection, that aren't involved in one that uses secondary data, for example, experimental design, procedure, stuff like that. Now, after that, once you know whether you're doing an experiment using secondary data, all of that, think about common daily problems in your day-to-day life. What are they? And are any of them biological? Do any of them have a biological solution? Do any of them have, are there any questions you have in your daily life that you feel have gone unanswered? Or is there any biological sort of phenomena that you're curious about, or that you want to experiment with, play with, tamper with, and you want to see how different things affect it? This pathway of thinking is essentially what should lead you to your IA topic. I thought of my chemistry IA topic while I was in the shower, and I was just like, I need a chemistry IA topic. Let me just brainstorm. Let me just, play with a bunch of ideas. Like, I know this, I know that. What can I do? And it just came to me. So that route of thinking is always useful because personal engagement is a very important part of your IA, and that shows what you've done to make your IA individual, why it individually relates to you, and something that has meaning behind it as well. Is there some personal reason, something about your life that the results of this IA or the topic of this IA relates to? Is there something that someone said to you, someone told you, something you saw, something you experienced? Or is it just a field that you're very interested in, a field that you want to pursue later on, maybe something that you're looking to do at university or pursue as a career? So you really want to tie it all up and have an explanation for why you're doing what you're doing. But sometimes it doesn't always happen in a very organic way. And in that case, the solution is to think about independent and dependent variables and use that approach to help yourself get to a particular idea. Essentially, any experimental IA is investigating the relationship between an independent variable and a dependent variable. So you're changing something to see a difference in something else. What you want to do is you want to make a list of dependent variables and independent variables for biology, and you want to think about what you can I think it's more helpful to think about the dependent variable, what you really want to investigate. Further, to help yourself get to a particular idea with that, you can think about different biological topics. So I have a few ideas here, I'm just going to read them out to you. So you could do something with enzymes, you could do something with plants, or you could do something with germination. You could investigate the content of certain vitamins in fruits or something like that. Or you could investigate how different factors affect the rate of respiration of a particular organism. Yeast is obviously the common one. So think about that, think about dependent variables. And then independent variables are pretty simple. So those will be things like time, changing the concentration of a reactant, or an added substance. Now, just to tell you the criteria for picking a good topic, now this is like a checklist that you should be able to check off, and your IA topic should meet all these criteria for it to be classified as a good IA topic. So there should be a scientific explanation supported by your background research to support your hypothesis or any sort of expected correlation. There should be a logical and doable experimental design for your IA topic. There needs to be a lack of existing research on the topic as well. So there needs to be a lack of identical research, so there shouldn't be a study that's investigating the exact same thing. However, there can be very, very similar ones, as long as they're not exactly the same. And those very similar ones will actually be useful in terms of creating your hypothesis or backing up different explanations. And lastly, the dependent variable should be quantifiable. So because that lends itself to data analysis, quantitative data analysis, and different statistical tests, and actually investigating the validity of your data through various mathematical procedures, which really levels up your IA. The next important part is structure. Now this is really long, so I'm going to rattle it off again really quickly to you, and I'm just going to mention a few points here and there about all the subsections. So obviously you want to mention your topic at the top of your IA, followed by your research question. So your research question is a broader question compared to the next one that's going to come, which I'm going to mention in a second. And it needs to it doesn't need to mention the exact independent and dependent variable, but sort of what correlation you're investigating, why, like in a more broader, relevant way. That's followed by your introduction. So this is where you mention, it's kind of like your personal engagement section, where you explain why you chose the topic, what led you to the topic, and then you explain the relevance of the topic as well. What use it'll have, or why does the result of your investigation matter. The next part is background research. So this involves different relevant information, existing information and theory surrounding your topic. So for example, if it's on enzymes, you want to include some basic information about enzymatic reactions, and then you want to specifically talk about a bit about the enzyme you're investigating. You want to talk a little bit about your independent variable, and then you want to mention at least 2 to 3 studies that are similar, and you need to use that to sort of lead to some sort of theory explaining the results you expect to see in your experiment. After background research, you come to the aim of the experiment. Now, this actually should state your exact independent variable that you're going to be altering, and your exact independent variable as well. You also want to mention the way that you're going to be measuring the specific things. So for example, if you're investigating rate of reaction, how you're going to be measuring it, and if you're changing the independent variable, what is your method of doing that? Very briefly in like a couple of words. This is followed by a hypothesis. So you want to have a null hypothesis and 1 or 2 or 3, I don't know how many ever, alternate hypotheses. And your alternate hypotheses should be backed up with a reasonable explanation for each one based on scientific evidence. Then you want to talk about your variables. So you have your independent variable, your dependent variable, and your control variables. So your independent variable is, again, you want to measure for both, you want to mention what it is exactly, the units that it's going to be measured in, and how it's going to be adjusted, changed, measured, etc. The method as well. And then for your control variables, you want to make a table. I'm going to throw a mock-up of the heading sections of this table and what they should look like. So it should include the variable, the method of controlling the variable, the reason for controlling the variable, and the reason for the value at which it was controlled. Again, all of these need to be backed up by some reasoning, some science, or some valid explanation. You want to make sure that there are at least 5 control variables to reduce the amount of systematic error in your experiment. This is followed up by materials. I generally like to split my materials up into chemicals, glassware, and miscellaneous equipment. You want to measure concentrations, capacities, least count, uncertainty for all your equipment wherever each thing is relevant. Then you want to go on to your procedure. Again, mention what's relevant under your procedure in different subsections. So for example, preparing your solutions, separate causing the reaction, and then the measurement. So split it into sections, make sure it's organized, because the easier it is to read, the easier it is to understand, the more the examiner will be impressed by it. Then you want to have a table of safety, risks, and ethical considerations. So make a table, and again, I'll throw up the headings for the table here. These are the headings I want you to put. Hazard, risk, how it can be minimized, and emergency steps or actions to be taken. Mention the ethical considerations after that. Then we have data collection. You have qualitative data first, so definitely mention whatever the qualitative changes are that you see in your experiment. For example, any changes in color, any changes in mass, volume, anything that's noticeable. Then you have your quantitative data. For your quantitative data, make a single table. That table should be well organized, and it should include units and absolute uncertainty. Then you have your data processing. This includes means, standard deviation, and propagation of your uncertainty, so finding your percentage uncertainties. Then a really important part of your biology IA, and this is usually specific to your biology IA, is your statistical tests. So you want to include a statistical test to prove the validity of your data. So there are a number of tests that you can use, the t-test, ANOVA test, or the chi-square test. So I don't remember too much about these because it's been a while since I've done them, but I can tell you the simple difference between a t-test and a chi-square test. So essentially, a t-test is for anything that involves numerical data. So testing the statistical significance of numerical data, so the difference between two means. So the mean for one set of data versus the mean for another set of data, is there any significant difference between them? Chi-square test is to determine whether there is any relationship between two different categorical variables. So I saw an example of this the other day, and that example was whether gender has any impact on which political party one favors. So that is two categorical variables, and if you collect a lot of data for that, you have gender, which is categorical because for this study it was classified into male and female. Then political party was also obviously categorical data. So you're determining whether gender has an impact on which political party is favored. So these are categorical variables. So to determine if there's any significant difference, you require a chi-square test. Then you have data presentation. So this involves graphs and diagrams. Make a clear graph that's well labeled and include your R-squared value as well on your graph. The more numbers you can show to show that your data is statistically significant, so the more you analyze it and evaluate it, the better you will do. So in data presentation, after you show your graph or your diagram, pictogram, whatever, you want to have a short analysis after that, and then we move on to evaluation. So evaluation can be split up into two things. So errors and improvements, and then limitations. So errors and improvements are some things that we can change in the experiment, and again you can use a table for this. I'll put the headings up again, and here they are. So you have errors, their significance, and how you can improve them. So the more of these more relevant errors you can find, so the better it is, because in a high school setting it's unlikely that you can perform the perfect experiment. So you should be able to find a lot of errors in your experiment, potential errors, forms of systematic error, and then obviously there'll be random error. You want to identify as many as you can and give a good explanation for why it's significant and how you can improve it, and this will really get you a lot of marks and a lot of points. And then lastly, in terms of limitations, I just like to mention a paragraph on a few limitations of my experiment. Things that I could not change, limitations of my lab at school, limitations of the equipment available to me, limitations in terms of how much time I had, things like that. So you want to mention those, and you can mention how, again, not having these limitations is going to improve your experiment. And that leads you to your conclusion, which is the discussion of your results. So there you talk about what your final result was based on your data. The statistical significance, you want to mention that, whether your data was looking significant or not, what the end result of your experiment is, and how valid your conclusion looks. And you can also discuss a few other things in there, such as the relevance of the conclusion that you found. So link it all back, sort of unwind your experiment. So start off with the result, unwind the analysis, unwind the evaluation, then unwind what that result means. So taking you back to your background research, to your personal engagement, and explaining the relevance of everything that you've just done and everything that you've just found. Lastly, mention scope for further investigation, and you're all set. That is your biology IA. Now I just want to take 1 or 2 minutes to talk about some simple tips for formatting. Choose a neat and simple font, label your tables and graphs, and use a clean, clear system of citation. Use whatever your high school recommends to you. Just make sure it's neat, clean, and you cite enough relevant studies to show that your IA is backed up by good scientific data. And lastly, I just want to finish off with some general tips. So firstly, go through your sample IAs available on the IBO website. I'm pretty sure they're still there. So there are like 10 sample IAs for biology, there are 10 sample IAs, 10, 15, I don't know how many there are, sample IAs for chemistry, and there's some for physics, just go through these IAs and first read the IA, then read the feedback and see what they are asking the students to improve on, how they want the IA to be better, what they appreciate about the IA, and definitely include that in your IA or adjust your IA accordingly. Then get your friends and family to read your IA as well. So definitely get your classmates to read your IA because their feedback can be really invaluable. Because imagine if all of you absorb certain information about an IA and then you share that, you all can make the perfect IA, because I'm sure everyone's topic will be different. Also, showing your IA to someone who does not do IB biology will be helpful. And that leads me to my next point. It's that you should use clear, concise language while keeping your IA detailed. That's why it's helpful to show a layperson your IA, because if they understand what you're talking about, if they can follow your train of thought, they can follow the flow of your IA, it just means that you've done a great job at communicating it. Maybe it's too simple, but that's unlikely to be the reason that they understand your IA really well if you've done a good job at it. So if they understand the flow of your IA and stuff like that, that means you've communicated well. Because think about it, at the end of the day, if it's not clear to the examiner what's going on, they're not going to give you the benefit of the doubt. They're going to mark you down for it. So that's everything I have to say about the IB Biology IA, IB Science IAs. These were all the tips that worked for me. This was the structure that worked for me. So I hope you found it useful, and if you did, then go and smash that subscribe button to join me for a lot more. Definitely drop a like on this video. Leave any comments you want, ask me any questions about IB, the IB Biology IA, or anything, and I will do my best to answer it. And try and share the video with your friends doing the IB program and worrying about their IAs right now. Hopefully I can help them out a bit as well. And with that, I will see you in the next one.